Hello to all you fellow experimenters. Backyard experimenter here. Wanted to show y'all this little circuit that I came across and finally figured out and put together. This is the toroid. It's a partnered output coil on a ferrite toroid, and then it's got a primary and a feedback coil. And if I can figure out how to do it, I'm going to post the schematic at the end of this video, and if I can figure out how to patch a picture into a video. But it's really simple. You take the output of the two partnered output coils and you bank it, you rectify it. I've got it halfway rectified right now, going into a 10 microfarad capacitor, and then that comes out and goes in. It's all parallel. The capacitor is paralleled across the output of the partnered output coil, and the bulb is paralleled across the capacitor. I will try to get that schematic uploaded to the video at the end. But anyway, this over here is the volts on the capacitor, and it's been some time since I've ran it, and it takes it forever. It goes down and then the capacitor will jump back up once it reaches the bottom, and then it'll start descending down again. And this is voltage though, right here. This is what the voltage reading will be. I don't know if you can see that in the screen or not. It's DC volts, and this is amperage. This will be the amp readings, what the load is drawing. So this is load amperage, and this is load voltage. I don't have enough hands or enough meters to get a voltage and input current off of this 9-volt battery, but I will tell you the 9-volt battery is not 9 volts. It's more like 6 when you load it, and I think it's about let me look at my notes. With the 6 volts, I think it draws about, I think it was 350 milliamps is what it showed, but I just don't know if that dead 9-volt battery can deliver 350 milliamps, but that's what the meter read. But y'all can do the math. So let's fire this thing up, and this is a 120 volt light, just LED light bulb, just like you would put in your house in a lamp or something. It's 14 watts is what the total draw when it's lit to full brightness is. 14 watts at 120 volts. So let's see how bright this thing will get. It looks to me like it goes about half brightness. Clip this on here. It's kind of hard to tell how bright it is, but it's about half brightness, I would say. And over here, that's the amperage, 4 milliamps. I've got it on the 220 milliamp setting, and it's 133 volts across the load, and that's the bulb. It's getting dimmer. Battery's about shot, but it's a really simple little circuit. You just take the output of your feedback, go into a resistor. Let me unhook this before I go to poking fingers around. This thing will knock the pudding out of you if you get hit by a capacitor. It stood me on my toes, so you got to be careful even with a dead 9-volt battery. But you come out of your feedback, and You go into what I've got here is a 266 ohm resistor going into a 5K pot, which then feeds into the gate of your transistor. And that is an MJ 13005, I believe. And that's it. I mean, it is really simple. And it puts out, I've done the math on the capacitor, and the capacitor, if you take 0.5 times the capacitance of the capacitor in farads times the voltage squared times the frequency of the voltage going into the capacitor, you'll get how many watts is stored in that capacitor. And I figured about 7 watts is what's being put in that capacitor, and that's the reason the bulb only lights about half brightness, I'd say. But I ain't got hardly anything on the toroid for windings yet, but I'm gonna scale it up, and we're gonna put 12 volts to it instead of 9, and we're gonna scale up the output windings considerably, and we're gonna see what we get. Thanks for watching. Hope you enjoy. Be safe and have fun.